And now let us go on to something totally different. Model ensembles. We won't finish it today, we'll finish it next time, which is fine. But today we'll actually get to see at least the simplest of this class of methods that we're going to look at now, which is model ensembles. Model ensembles are actually now getting into the more recent machine learning ideas. The stuff that we saw up to now, appeared in the 50s, 60s, 70s, 80s. Now we're getting into the 90s. Okay? We're covering a lot of decades, as we go through the class. So what is the idea of model ensembles? And model ensembles is something that is really worth knowing about because it's not very complicated and it can really improve your accuracy. The basic idea in model ensembles is very simple, is don't just learn one model, learn a whole bunch of them. Part of what gave people this idea, actually people can make model ensembles from a whole bunch of different directions, but one of these directions is a very natural one, is like, people spend their days trying different versions of algorithms and different algorithms, and then they threw everything away and just kept one. Couldn't you really do something better with all those different variations that you tried? The answer is yes, you absolutely could, and we're going to see how. Okay? So, the payoff of learning model ensembles is that you get better accuracy, sometimes a lot better, sometimes shockingly better, right? Often with a very small addition to the algorithms that you already had, right? You already have this big bang of implementations of, decision trees and neural networks and naive Bayes and whatnot, and now you just have to wrap something around it and suddenly your results get much better. On the other hand, there are two downsides, right? An obvious one is what? Speed, right? This is going to take longer, right? And the other one is, again, a model ensemble is going to be more opaque than just, say, a single decision tree. But again, you can imagine, and again, there are, there's been work about that. Actually, I did some of it, come to think of it, on extracting comprehensible models from a model ensemble. Like I have an ensemble of trees, and I'm not trying to get a single tree that best approximates that. Okay? So, model ensembles, again, are not the panacea. They do have some disadvantages, but nevertheless, they're well worth knowing about. Some of the conventional wisdom is that some of the most accurate classification methods that exist today are model ensembles. Okay? And in fact, when you care about accuracy, almost nobody these days just goes and learns a decision tree, for example. They will learn an ensemble of them. Now, there's a whole plethora of methods. We're just going to look at four of the most important ones. The first one is bagging. Also, historically, the first one. And also the simplest one. This is a really simple method. And it's one that, is going to be in your homework. And then boosting, which is a fiendishly clever idea. We'll talk about it, probably next week. Boosted decision trees are generally considered, if I had to just give an advice on what would you use for maximum accuracy, it wouldn't be naive Bayes or nearest neighbor, right? Or even the single decision tree. It might be something like boosted decision trees. Okay, so well worth knowing about. And then we will look at two more. Error correcting output coding, which also does other things for us besides improving accuracy, as we'll see. And stacking, which is a representative of a very large family of what are called meta-learning methods. Stacking is I'm going to have a learning phase where the inputs to the learner are what the other learners did. Okay? Stacking is what really answers this question of I've learned all these models, can't I do something with them? Stacking is a good answer to what to do with them. Okay? So we're going to go over these. Again, there's many more, but these at least give you a good picture